The commutator of two Hermitian operator is what? Right? So let us take this commutator and try to solve this problem. So it says, let us take, if A and B are two Hermitian operators, right? It means that A dagger will be A and B dagger will be B. Right? This is the general property we have. Let us take it as equation number 1. Now, what is the commutator of A and B? A and B as an operator gives you A cap B cap minus B cap A cap. Remember that these are operators. Now let's take the Hermitian conjugate of this. Right? What does it gives you? AB का whole Hermitian conjugate minus BA का whole conjugate. Right? Now remember that product of the conjugate of the product of two operators will always, for matrices, will always exchange. Right? So it will be B dagger A dagger minus A dagger B dagger. Now it just switches. So let's take common. Now A dagger B dagger minus B dagger A dagger. Sorry, let's simplify it rather here. Now B dagger is B and A dagger is A. So it gives you BA minus AB. Right? You started from AB minus BA, took Hermitian conjugate and you got this. You take minus common, it gives you AB minus BA. Right? And this is what? It's commutator of A and B. Right? With minus sign. So what does it mean? It means that the Hermitian, commutator of two Hermitian operators is not Hermitian, rather than anti-Hermitian. These kind of questions are usually asked in the gate, and it can be asked in anywhere, but you should always remember this property of the matrices or operators. Basically, operators are matrices, right? So they follow the properties of the matrices. So this problem number 32, which is about the operators, says that which of the following operators are Hermitian, right? So first is DDX, second is I of DDX, and third is E to the power DDX, and fourth is I D of DX, right? So let us take one by one. The first operator which you need to remember is Hermitian conjugate is what? Now this is one important aspect you need to remember, that Hermitian conjugate of plane operator of this differential operator is always negative. So they are not Hermitian, rather than anti-Hermitian. This is one important result every physics students should remember, right? The second one is I ddx whole. Remember that I ddx is nothing but your momentum operator, obviously multiplied by h cut, right? So I goes to minus I, and this goes to minus of ddx, giving you what? It is as I ddx, which is Hermitian operator. Right? You started from the same and you got the same. So that's why momentum operator is a Hermitian operator. Remember that. The third, e to the power ddx, it will be same. Remember that These terms, exponential, logarithmic, these are all terms of any Hermitian operator will be Hermitian and anti-Hermitian will be anti-Hermitian. Right? So it will be simply giving you, so it's an anti-Hermitian operator. And fourth one will be that's Hermitian. It remains unchanged, just like this. So this is important result which you must remember. How the operator DDX or differential operator will behave, or in what category they lie, in the Hermitian or anti-Hermitian. Right? Now we will go to some more problems one by one. Number 33, which says that consider two operators A and B defined by A psi x equals to psi x plus x and B psi x equals to d psi by dx plus 2 psi x. Find out whether they are linear or not. Right? So what are the linear operators says? It says that operator A plus B psi 2x gives you A psi 1x plus B. Right? This is what the linearity condition is that. Now we will check whether these operators satisfy this condition or not. So let us go to the first one. Now when you will apply this A operator, or you can write it C1, C2. It's C1x right? So A operating on C1 psi 1x plus C2 psi 2x, right? The two wave functions are there. So what does it gives you? It simply gives you a psi x, then it gives you psi x plus x. You can assume this as the entire as some psi x. So it gives you C1 psi 1x plus C2 psi 2x plus x. Right? This is what you get in the LHS. Now, if you go to this side, so C1 A cap operating on psi 1x plus C2 A cap operating on psi 2x, right? What does it gives you? It gives you C1 psi 1x plus C1x plus C2 psi 2x plus C2x. Right? Now you can see you have LHS, you have RHS. Both are not equal to each other. Right? Not equal. It means that A is not a linear operator. Not a linear operator. Right? Now let us go to the B to understand the same thing. So this is simple. You applied and you found this, and you found that they are not equal to each other. So A is not a linear operator. We note it down. Now let us go to the B and try to understand it. So for B, if it is operating, gives you how much? it gives you ddx of this entire wave function c2 c1 psi 1x plus c2 psi 2x plus 2 c1 psi 1x plus c2 psi 2x. Right? Which can be further simplified to write ddx of c1 ddx of psi 1x plus c2 ddx of psi 2x plus 2 c1 psi 1x plus 2 c2 psi 2x. Right? Which can be written as c1 ddx of psi 1x plus 2 psi 1x plus c2 ddx of psi 2x plus 2 psi 2 c2 psi 2x. Right? So what does it mean? This is nothing but c1, sorry, here it is c1 b cap operating on psi 1, because b cap operating on psi 1 gives you ddx of psi 1x plus 2 psi 1x. You take c1 common plus c2 b cap of psi 2x. So you started with this, and they are equal. LHS from you started from LHS and H to LHS. It means that B is a linear operator. Linear operator. Right? So this is your problem number 23, which is about the linear operators. Please note it down. Now let us take this question, which says that describe the important properties of projection operator. So projection operator is one of the important operators, which is usually asked in the exam. So it's the projection operator. The important property is first, it is equals to its own square, and it is Hermitian. It means that P equals to P diagonal. Right? This is one property. And then second property is that it is represented by this. Right? P equals to this, where psi is normalized. Remember that. This is the third important property. Sorry, second. And third important property is that two projector operators are said to be orthonormal if their product is 0. Right? If P1 is there and P2 is there, the dot product is there. If it is 0, so psi 1, psi 1, psi 2, and then psi 2. Then if it is 0, the inner product will be 0, right? They are orthonormal. Their inner product will be 0, it will remain 0. So they are orthonormality. So projection operators are orthonormal, then this is the case. And one important property which is one must remember, product of two projection operator is not necessarily a projection operator. right? It will be projection operator when product is Hermitian. Like P1 is Hermitian, P2 is Hermitian, right? So P1 dot P2 must be Hermitian. This is P2 dagger, P1 dagger, which is P2 P1. Right? If this condition is P1 dot P2 is equals to P2 P1, P1 P2 equals to P2 P1, then only this will be the product. This also will be a projection operator. Otherwise not. Right? Remember that. When product is Hermitian, then it is a projection operator. If it is not Hermitian, then it is not a projection operator. So these are some of the properties of the projection operator, which can be asked in any of the exam. So please just remember it whenever you are going for an exam. Just try to recall it. Right? Now let us discuss problem number 35, which says that consider a case psi, which is 5 by 2 minus I, and this is not normalized. It can be normalized by multiplying it with the factor of 1 upon a, root a, where a is what? Now to normalize it, you know that their product must be unity, right? The wave functions, the probability must be unity, so the product of the size must be unity, right? So they must be divided by the factor. This is equals to 1 of this inner product of the two values, root of the inner product of the two values, right? So just calculate it. So what is this? Let's convert the Hermitian conjugate of this. Let us convert the Hermitian conjugate of this, right? And how much it is? So Hermitian conjugate of this will give you minus 5i, 2 and I, right? And this goes to minus 5, 2 minus I. Now just take a multiplication. It is 5, 525 minus I is 25. I square is minus 1 minus multiplied by 1, right? It gives you 25 plus 4 and this plus 1. It gives you 30, right? Now, to normalize any of the wave function, you have to simply multiply it with the root of this value, right? So it is normally written in this to normalize wave function, so we call it. Whenever you are calculating the expectation value of an operator and wave function is normalized, you have to divide it by this to make it unity, right? So the value of A is nothing but root 30. So the wave function will be, psi will be 1 upon root 30 5 by 2 and minus 1. Right? So this is simply normalization factor, right? If you divide it by each one, like a bracket by 1 upon it will normalize the wave function. It will give you the probability as unity, right? So this is all we have. Now we will come with some more number of problems in the next lecture.